how did we fix and address such problems with AI? Obviously, with an AI assistant that answers user questions. So what happened? The mechanics and the users found really difficult to maintain their cars and to solve also easy problems. And obviously it was clear that nobody read the documentation. There was a lot of issues that were managed by the tech support, and even those questions that could have been easily solved by reading the documentation.
We are going to show you a little bit of a demo of our application. As you can see, the interface is pretty simple. There's the document on the left side, the chat on the right side, so that the user can see if actually the response is good, because there's a hot topic of who's responsible of what the chatbot says. We solved this kind of problem by putting the human in the loop, so the user can always double check if what's said is right or wrong and take his own decisions.
Hi everybody, my name is Christian and I'm here with Luca, and today we are going to present unlocking documentation with AI-powered chatbots, a real-world case study. Before that, we would like to say something about us and about we love to work in our work, let me say. And we'll start with our motto, your way into the future. We are passionate people, and this passion led us to create Memoria. In Memoria, our objective and our goal is to guide customers one step at a time towards their technological future. I would like to highlight the your way part of our motto, because it's true that we will follow our customer on the road to their technological future, but they will be on the driving seat. Memoria, born 2 years ago, and is a venture of Intre, which is a software house based in Monza. And we are here today in order to tell you something about how is going on in our venture and how we approached some projects. We have two main areas in Memoria. The first one is projects, and the second one is knowledge. The first one is about creating projects, obviously, and the second one is about sharing our knowledge to the ones like events like this. In the project areas, we create cutting-edge and tailor-made projects, and obviously, in order to do that, we first analyze the needs and the requirements of our customers, because we really love to do things that are useful for our customers, not things that are parked somewhere and not used anymore. We build projects through an incremental development approach. So at the end of every sprint, the customers could see something about what we have done. In addition, we have also all the skills needed in order to do the project from an analysis phase to the delivery of the entire product. About the knowledge, since we want the customer to be on the driving seat, we are more than happy to give him the knowledge that he needs to drive safely. And that's the reason why we love to share our knowledge through events like this, or also through one-by-one mentoring to the customers, or through online courses. So let's start talking about Macchinone, which obviously is not the real name of our customer. Macchinone is a company that makes some pretty impressive cars, motor vehicles, and they are quite complex. And for that reason, they are shipped with a very big documentation. So what happened? The mechanics and the users found really difficult to maintain their cars and to solve also easy problems. And obviously, it was clear that nobody read the documentation. This happens also for us. So there was a lot of issues that were managed by the tech support, and even those questions that could have been easily solved by reading the documentation. In addition, the same questions were asked repeatedly, and that was a real problem for the tech support, which was really which were really struggling to manage the volume of incoming calls that comes for those repeated questions. So how did we fix and address such problems with AI? Obviously, with an AI assistant that answers user questions. First of all, we would love to talk about how we achieved this result. As we said before, we really love the agile approach, the incremental and iterative development way. And we have released small and valuable features, and after each sprint, the customer give us a lot of feedbacks in order to improve the project that we were working on. So, since we work in an agile way, we thought that it was a great idea to present this talk like a sprint review. So we will go through all the sprints, talking about the goal of a sprint and how we reach this goal. So let's start with the first sprint. And the goal of this sprint was just building a simple and easy web app in order to allow the customer to test it out. The architecture of this web app was quite simple. In fact, there was an easy interface where a user could do some inference, do some questions. And behind this web app, there was just an OpenAI assistant that answered to those questions. Obviously, this OpenAI assistant was shipped with the document knowledge base, because obviously we were talking about motor vehicles. So during the first sprint, there was a question that comes to our minds many and many times. Should we use OpenAI or a custom model? So we obviously choose OpenAI for some reasons. The first one is the fact that we would like to maximize the results with minimal investments. In fact, the customer was not ready to make large investments in this product. They just needed a POC, something that they could test it out, even in production, and make some tests. In addition, OpenAI is the state of the art for the off-the-shelf and cost-effective API. So there was and there isn't such cheap and efficient solution available in the market. We also like to use best practices. So we tried to avoid the vendor lock-in also for the model. So the architecture that we have built is meant to allow us to swap the model whenever we need. We don't want to be the one who draw 25 cards. So at the end of the first sprint, the CEO of Macchinone, which is Chuck Norris, obviously, was quite happy about the result, but it wasn't obviously enough. After the demo, a lot of feedbacks comes with a lot of new feature. So I leave the stage to Luca, which will talk about the second sprint.
Thank you very much, Christian. And as we said, we're going to go through the second sprint and the third one we made. So in the second sprint, the goal, the feedback that the customer gave us was that responses were good, but there was no reference to the document. And specifically for technical problems, a simple response wasn't enough. Even because inside the document they gave us, there were also images that were very useful to be seen by the people that were chatting with the bot. So we started thinking how to implement this kind of feature and retrieve the page in order to be able to show the document at the point where the information were extracted. So with the same mindset of avoid building things that was just present, we looked at OpenAI messages annotation, which are a feature that can be enabled inside an OpenAI assistant. And what they do is like when you get a response from an assistant, it will contain an annotation. An annotation looks like something like that, with some braces and a number and a strange cross with the source that references a point inside the document, the point where the informations were extracted from. But sometimes, but in real case, it was pretty always the response contained no citations, and we needed a consistent one. We needed a consistent citation to the file in order to show the user. Plus, we needed a page reference. So we needed a specific page, not just a citation of the document, because the user wanted the document on the other side of the chat. Then we will show you a demo of the application, you will see. So to do that, we built our own vector space. But first, I would like to ask you if some of you is familiar with this kind of concept. Who knows what a vector space is? Can raise his hand? Okay, but not so much people. So we're going to do a brief introduction of what a vector space is, and so that it will be easier to understand the building of this concept. So a vector space is an n-dimensional space. So, for example, here you can see a 3-dimensional space in the image. In this space are placed some items. The coordinates of these items are called embeddings. So you can embed everything, okay? So, for example, let's take a look at the example. It's like a t-shirt. I can embed a t-shirt or convert it into an array of 3 values and map it into a space. But vector spaces have some properties. So you use some models to generate those embeddings so that these properties are maintained. Can some of you tell me what property is one of the most important one inside the vector space? The? Yeah, that one represents how complex the representation is. But that's a good point. The most important one, as you can see from the photo, from the GIF, it's the t-shirt is mapped into a place inside the space near other t-shirts, because its representation contains the feature of the image. So image with similar features will be placed closer into the space. As you can see, there's some clusters with t-shirts in red. For example, there's pants in blue and scarves in green. So this is a very important property for a space, because if you imagine it with an image, you can do it also for any other object. For example, text. You can take a paragraph, a piece of text, extract its semantic features, and map it inside a space. Therefore, you will get, for example, if you map an entire document, it will be easy to find, given a phrase, the most similar items of the document that shares feature with that one. Plus, it's incredibly fast in performances. It has huge performances in search, because searching inside a vector space is pretty fast. And we wanted something fast because we know every user when he's going to use an application, if it's not responding in 3 seconds, he's probably going to refresh. So we will give the guy who tried to answer the question a t-shirt of Memoria. It was a little present. So let's see how the vector space is built after I explained you a little bit. So we take the document, we split it into pages, and then for each page, since the page was the granularity we wanted to obtain, we generate an embedding representing a point inside a vector space that is stored inside a vector database. We chose Qdrant. Qdrant, a brief introduction, is a vector database, as we said. It offers really good performances in search. It allows to store embeddings plus metadata. So we store the embedding and the original page reference so that we can search the embedding and retrieve the page it was referencing to. It's possible to choose granularity. Always the mindset of not locking in to a specific solution. Things can change because we use an iterative approach. We choose the granularity. So, for example, now it's a page. Tomorrow it could be a paragraph, a phrase, anything you want. It's model independent. Same thing as before. And last but not least, it's open source. So it allowed us to not charge any other money to our customer. So the web app that showed you Christian before looked like this. Let's see how it changed after this iteration. So the response from the assistant is then embedded with the same model we used to embed the pages, so that we can obtain a vector of the same dimension that is compatible to be searched inside our vector space. And we use Cousin similarity between vectors, which is a method of searching most similar vectors. And we retrieve the top 3 most similar vector, which represents the top 3 most similar page that would be the one that contributed to the response of the assistant. We choose 3 because if we talk about topics that are spread across the document, there's maybe not just one page that contributes to the response, but 3, we tried it, we saw it was a good number. It's a magic number. So the response looked like this. We sent back to the client the original response of the assistant plus the pages, so that we can search inside and slide through the document. Second sprint review, Chuck Norris was again very happy, but it wasn't enough, because the customer always asked us to create this vector space for each new document he was going to add to the assistant application. He was building many types of machines with many different documents. We started with one machine, and after he saw that it was working, it was like, how can I add another one, and start making some other questions. And we didn't have a way to build autonomously this space. So the third sprint aim was to generate the vector space I showed you before automatically. Easy. This was the process I showed you before, just to have a recap. And the first thing that comes to mind when you talk about automating something nowadays is a pipeline. Use a pipeline and automate it. We searched a bit on the internet and for the technologies that were available, and we chose Haystack. Haystack is an open source framework for building production-ready LLM applications with retrieval augmented generated pipelines. It's like a mantra. And it supports many models. OpenAI was one of them, of course. OpenAI ADA model, which was the one we used for the embedding. It's flexible, therefore you can swap the model. You can use Google, OpenAI, anything you want. It's scalable. In the hopefully future where we will need to create so much assistance, we can scale the pipeline as we want and be able to handle the creation of multiple vector spaces all at once. Lastly, it's open source. And again, it was free for us to use. So the pipeline is made of blocks. We'll show you a little bit how it's composed and what are the parts that are building the pipeline. We start with the document. The document is then passed to a block, which is the converter, that takes the PDF document and converts it into a more easy parsable document for us to parse, which is not a complex block, this one. Then there's the cleaner that takes the parsable document from the converter and removes all the blank spaces, blank lines, stop words, that kind of thing that don't need to be in the document or could cause some problems. There's the splitter, which is the one in charge to split the document into pages, as we saw before in the architecture image. And then there's the embedder, that takes the output of the splitter, so each page, and embeds it with an OpenAI, in this case, ADA model. And last, there's the writer that writes those embeddings with the metadatas inside our specific Qdrant collection with the name of the document, so that we can store multiple things. So, third sprint review, Chuck Norris was finally happy. He was not arguing anymore, and we are going to show you a little bit of a demo of our application, just to see what in practice what I just presented to you. So let's see if everything is up and running. This one is okay. Okay. As you can see, the interface is pretty simple. There's the document on the left side, the chat on the right side. There's the possibility to switch between different assistants. For example, now, since the customer is Macchinone, we uploaded some Toyota documents just to test and show the use case. And so I can switch between Prius and CHR machine. Then I can see the document on the left side. I can scroll through the documents. I can go to a specific page. Otherwise, I can also ask a question to the assistant. For example, let me ask him, talk me about the anti-intrusion system. He's going to think, and now he says what's written in the document. I don't really know. And as you can see, there are 3 references of the pages that contributed to this response. The first one is automatically brought to the left side, just so that the user can see if actually the response is good, because there's a hot topic of who's responsible of what the chatbot says. We solved this kind of problem by putting the human in the loop and always show the document, so that the user can always double check if what's said is right or wrong, and take his own decisions. So since it's an assistant, I can always chat, and he keeps the context. For example, I can say like, and how do I deactivate it? I don't need to specify again that is the intrusion system. Is pretty straightforward. He says how I can activate the intrusion system, and it brings me to the page. Again, I can go to another page. For example, I can start a new chat, change the assistant. For example, I can go to the CHR assistant and ask him another question. For example, I need to, I have a pregnant woman on board. Are there some things I need to keep in mind? And let's see. He answers And it brings me to the seatbelt and pregnant woman section of the document. It's pretty straightforward. Now, after this brief demo, we're going to show you a little bit of the code that's behind this piece of code. So we want to show you the pipeline, which is like this, because when it was shown in the presentation, maybe someone can think it's pretty complex to build, but it's not that really complex to build. As you can see, I can zoom a bit, sorry. You can see. Let me try. Better? So you can see with Haystack, you can easily add components to the pipeline. So you say there's a converter, which function is py PDF to document. There's a cleaner that's running this function, document cleaner, and so on. And then you connect those pieces together just by using .connect, pipeline connect, and you attach every piece together. Another piece of code we can see, it's, for example, the sentence retrieval API, which is the one that is called when we get the answer from the assistant. We call this endpoint to get the most similar pages. So we call sentence retrieval inside our Qdrant store. How does sentence retrieval look? It's again another pipeline, another Haystack pipeline that embeds the response and then goes and search inside our vector database for the most similar items. Then we clean the most similar item based on a threshold that we just set by trying and seeing what was good for these kind of documents, so that we can send back the responses to the front end. That's it. So I'll leave the word again to Christian, which will end this presentation.
Thanks, Luca. Again, that's our motto. That's the way we work with our customers, and we really hope that you enjoyed these presentations. We are here, we have a stand here, so if you have any question, if you would like to tell something about your technological future, we are more than happy to hear you and talk with you about that. I hope that there's any questions.